Hello everyone, my name is Syed Asad Rizvi. I am a student of MS Data Science and the topic of my project for MS Project course is leveraging quantized LLMs for sentence boundary prediction in transcribed Urdu text. I have made this project under the supervision of Professor Dr. Sajjad Haider. The objective of this project was to provide an effective solution for the textual issues that usually occur in the Urdu language transcriptions obtained from speech-to-text applications. The major issues that occur in these transcriptions, which are highlighted in this project, include punctuation and sentence boundaries that are incorrectly placed in the Urdu text. This project presents a solution based on the usage of large language models, which are used in the project to predict the correct positions of punctuations and sentence boundaries in the Urdu text. For the sake of simplicity, only commas and full stops are considered in the current solution, while the rest of the punctuations can be taken in future work. The dataset used in these solutions include Urdu transcriptions obtained from OpenAI Whisper, which is a speech-to-text model. Moreover, different e-newspapers and stories are used to collect the Urdu language text so as to prepare sentences for experiments. The techniques which are implemented to handle punctuations and sentence boundary issues include one-shot learning, in which a correct Urdu sentence is provided in the prompt as an example, and based on that, the respective LLM will predict the position of the punctuations in unpunctuated Urdu sentences. Various large language models have been experimented for this purpose, but the major ones that gave considerable results include Llama 2 and Vicuna. Both 7 billion and 13 billion parameter models are used here. Also, an important thing to note is that 4-bit quantized models are used instead of normal models, as they give equally better performance on the Urdu text. In this solution, 250 unpunctuated sentences were taken for testing, while Llama 2 and Vicuna LLMs with both 7 billion and 13 billion parameters were applied on these sentences. Upon experimentation, the average scores of the evaluation metrics, precision, recall, and F1 scores show that Vicuna 13B model gave the best performance as compared to the other models used, and it took almost around 6 hours to execute 250 sentences. The best score was around 55% produced by Vicuna 13 billion model. Another LLM-based method which is explored in this solution is fine-tuning using Q-LoRa technique. Llama 2 7 billion model is fine-tuned in this method, and training is done on 2000 Urdu sentences, while in the testing phase 1000 unpunctuated Urdu sentences were taken for experimentation. After testing, it was observed that the results obtained by fine-tuning were not satisfactory, as it was producing output sentences that do not belong to Urdu. So these were the solutions implemented in this project along with their subsequent results. An application to generate the punctuated Urdu sentences with one-shot learning is also developed through Streamlit. It takes an unpunctuated Urdu sentence as an input from the user and generates its punctuated version. In the future work, different large language models can be used and their performance can be observed. The number of sentences can also be increased from 250 to more based on the available computational resources. This was all about the project. Thank you. This is the demo of the application which is created using Streamlit. In the beginning, the large language model Vicuna is loaded at the back end. Then in the application, it takes an unpunctuated Urdu sentence from the user as input and initiates the one-shot learning process as described earlier. The example provided in one-shot learning technique is same for each sentence, and based on this example, the application is running. Here you can see the predicted punctuated sentence in the output. As we have discussed, we have only considered Urdu commas and full stops as punctuation and sentence boundary respectively, which you can see here in their predicted positions. This was all about the application demo. Thank you.